This is the first of a series of videos on conditional probability. And the first thing we would do is introduce some notation and talk about what we mean by conditional probability. So if you think about the probability of an event, sometimes the probability of one event depends on another. So the notation that we're going to use is probability of A and then a line B. And that means the probability of A happening given that B has happened, or that B happens. It turns out that mathematically it doesn't matter that whether or not B has already occurred or whether or not B will occur. So for example, let's say the probability that you pass your history test is 80%. Well, that's just the probability that you pass your history test, but in fact we know that you have two options. You can either study for your history test or not study for your history test. So what you can do is you can say, well, what's the probability that I pass my history test given that I study for 2 hours? And let's say that's 91%. Well, this is just a straight probability. What's the probability of something happening? This is the probability that one thing happens given that another thing happens. And sometimes that's given and sometimes that's something you can figure out. So let's do this. Let's look at cards again because cards are such a good example. So let's look at a deck of 52 cards. And let's remember there's 13 hearts and there's 12 face cards and there's 4 jacks. So the first thing is you could say, let's pull one card. What's the probability of heart? Well, 13 out of 52. If you pick a single card, the probability of face card will be 12 out of 52. And the probability that you take a single card and you get a jack would be 4 out of 52. Now let's look at this question. Let's look at the probability that you pull a jack given that you know it's a face card. So we could be playing a game. So here's an example. We're playing a game here. You win if you get a jack. I pull a card and I say, and I'm just kidding with you or teasing you in a sense, and I say, I bet you that this is a jack, and I tell you what, I'll guarantee it's a face card. Well, if you know it's a face card, you can calculate what's the probability that it's a jack given that you know it's a face card. Well, if you look at each one of these problems, the denominator in each one of these cases was the total number of cards. So you have to think about what's the total number of cards here. Well, if you know it's a face card, then there's only 12 cards that are face cards, so you know the denominator is a face card. And now let's figure out what the probability of a jack. Well, how many jacks are face cards? Think about how many jacks are face cards. Let's think that through. Jacks are face cards. Well, 4 are. So that's 4 out of 12. Or about 33%. Now compare that to the probability of a jack straight on, which was 4 out of 52. Let's figure out what that is in a percentage. If you do that as a percentage, that's 4 divided by 52, or around 7.7%. And if you notice, the probability of having a jack changes a lot if you know it's a face card. Let's do another example here. In this case, let's look at what's the probability that's a jack given that you know it's a heart. Well, in this case, the denominator is how many hearts there are. In this case, there's 13 hearts, right? Because same game, I pull a single card out. I said, I guarantee that this is a heart. What's the probability it's a jack? Well, then what you have to do is you have to think about, well, how many jacks are there that in the set of hearts? And there's only one, so it's 1 out of 13. And let's look at 1 out of 13 real quick. 1 divided by 13 is about 0.077. And if you notice there, the probability of a jack straight on is 4 out of 52, which is also 0.77. Let's do another quick example of conditional probability. Let's look at the probability of A given B. And let's look at it in terms of a Venn diagram. Let's say you have an entire set which is a total of 100. And then you have A, which is 30, and B, which is, let's say, 40. So we can quite quickly calculate the probability of A, 30 out of 100. Probability of B is 40 out of 100, or 0.3, 0.4. Now, if you notice on this case, though, it's possible that A and B overlap. So let's say A and B overlap, and this is 11, right? So you could say the probability of A intersection B, or A and B, is 11 out of 100, or 0.11. And from algebra, then, we can figure a whole host of things. But rather than doing that, I'm just going to use the picture. Well, if this is 11 and this is 30, then that means that's 19, and that's going to be 29. And quickly, what you can do is you can figure out the probability of A or B will be 19 plus 11 plus 29 over 100, which is 59, I believe. .59, right? So we knew how to do this all before this video. Now let's look at conditional probability, the probability of A given B. Well, here you know B has happened, right? So B has happened, so that's the denominator, so that's 40. And now, on the numerator, you have to think about what is the probability of A happens when B has already happened, right? So B has already happened, so those are the only 40 that matter. And then here, this is 11. So your final answer is 11 over 40. Why 11? Because you know that B has happened, right? So you know here that this is the relevant set of numbers right here, right? Because you know that B has happened. And of the times B has happened, A happens 11 times. And you have 11 divided by 40. And you get about 28%, or exactly 0.275, 27.5%. And that's how you do conditional probability. Now, we could use formulas here. You will use formulas in later classes, but for now, draw a picture is probably the easiest way of doing it. And that's the video.